To Engineer Prabodha Jinisena. Let me introduce about Dr. Tanuja Aryanand. He is the Chief Executive Officer of Lanka Rainwater Harvesting Forum. It's a non-profit organization and non-government organization, especially for the rainwater harvesting. He obtained his BSc in Honours in Applied Biology from the University of Wales, United Kingdom. And after that, he got her MSc in Aquatic Resource Management from the King's College London, United Kingdom. Then the PhD in Environmental Science from the University of Kelaniya, Sri Lanka. In locally as well as internationally, he was the director for the Women's Program in 2001 to 2003 of the International Rainwater Catchment System Association and author of several books on rainwater harvesting. She published more than 25 research papers at the international and national forums. Also, she is the conveyor for the South Asian Rainwater Network. Since Mr. Prabodha Jinsen mentioned about his father, I don't want to excrete it. So, with this brief introduction, I cordially invite Dr. Tanuja Aryanand to deliver.
Thank you to the publication, Library and Publication Committee for inviting me for this occasion and also introducing me. Yeah, as both gentlemen said, this is really my father's domain. So although I have come to you, I'm sure he will be proud if he was here that I am lecturing here as well. So without further ado, I'll start on my topic, sustainable solution for rainwater harvesting. So we are talking about SDG goals, which we have to meet in 2030. So water actually is connected with most of these SDG goals, whether it is hunger, eliminating hunger, or poverty, good health, education. If you have water, you have also can ensure good education quality. Gender, of course, because water is linked with women. Sustainable cities, reduce equality, climate actions, for mitigate climate, and also for the environment. So many of the goals are linked with water as life is linked with water. So if you look at the present, at least during 2020, the water situation and access to water supply, if you take the world, it has not done much during the last 20 years, I suppose, 10 years at least. There are still people who doesn't have access to good quality water. If you look at the least developing countries, this situation is even worse. If you take Sri Lanka, about 60% of us has pipe water supply, but 40% doesn't. They have to rely on other sources like wells, springs, valves, etc. And as you know, due to climate variabilities, this is not always ensured as good quality water. So how do we bridge this gap, the 10-11% gap, which doesn't have good quality water or access to good quality water? One is to conserve because water is not a resource that is has a boundaries. So we need to save what we have. So we need to conserve and save water. We have especially for domestic and water supply, you have to think about rainwater harvesting and also to reduce the runoff, store and charge recharge the aquifers. So integrated water resource management at the watershed level, ecosystem protection level it should be the approach we should be taking on. So rainwater harvesting, what is rainwater harvesting? Is basically collecting rainwater when it falls, where it falls, and storing and using for the dry season, not when when it is not raining. So there are two ways you can do. We can store in some sort of vessel with some sort of reservoir, etc. Also, we can recharge the ground, use the ground itself as your storage. So these are the two methods we can do rainwater harvesting. If you take as globally, how many people are using rainwater? Of course, we have been using rainwater for many, many centuries. As you all know, it's been traditionally, all our wells are all using rainwater, collecting rainwater. But during the last 30 years or so, there has been revival of this technology. So people around many countries have been taking rainwater harvesting. And as of 2022, there has been 130 million people who have been using rainwater harvesting for domestic consumption and expected to rise to about 160 million in the coming years. So why do we need rainwater harvesting in this sense? Of course, water is stress, and stress is growing not only in Sri Lanka but around the world, more so around some other countries. Why? Because of human activities, increasing populations, urban development, and of course, pollution of the water sources. And then the climate change, drought and floods. No, we no longer, I think, have monsoon rains. We have drought season and flood season. So this is constant. So we need to, that is why we need to restore, recharge, retain, and reuse, use the 3 R's, the rainwater we have. Okay, so where and why do we need to store and collect? Especially in the arid areas, in higher elevation where there's no water, spring water or water source, we need for household needs as well as for agriculture needs. And in areas where water is, the groundwater is poor in quality. Could be coastal areas where the wells have saline water. This was increased especially after the tsunami. Then in areas where there is high content of iron or brackish water, especially in the dry zone areas, and also in areas where the groundwater has arsenic. Thankfully, not so much in Sri Lanka, but in places like in Bangladesh, which is very prevalent. We have, but still we have fluoride issues in some parts, and also CKDU areas, the chronic kidney disease of unknown etiology. Many people link it to bad quality groundwater. So those areas also rainwater harvesting can be introduced. And it has better service, believe it or not, because you have the storage at your home. So you have more water security. If the water board suddenly decide to go on strike, you don't have to go looking for wells or some other source or wait for the Bowser to come. You have already a water supply in your own home. So it's more water secure. If you have places, the dry season, when there's no water, when there's no rain, so it bridges the gap for water storage or water shortages. And for a rural house, it is water at your own doorstep. You don't have to go long distance in a wet, hot sun looking for water. It is at your home. This was very much emphasized during the COVID time when there was lockdowns, there was curfews. If you imagine a rural house, which usually has to, or mostly ladies, who has to go to the nearest well, it could be 1 or 2 kilometers even, or even shorter, but still has to go to get the water. But when there's curfew, how can you go? So in households where we had rainwater system, 90% of them had water. They not only had water for drinking, they also had water for their washing and hand washing, which was very much encouraged at that time during the COVID. Not only that, they also were able to share that water with their neighbors who couldn't go out. So that was a very plus point for people who have rainwater system. Then it saves money because if you have supplement your water system with rainwater, you can reduce your water bill up to about 60%. It depends on, of course, on which level tariff you are in. If you are in a higher tariff rate, then your water bill can get reduced to about 60% because you will come down to a lower tariff rate. So that is the advantage, and of course saves energy. As you all know, those of you who are water board engineers will know how much energy you are using to distribute water. I think about 80% of their cost is for energy. So if you have at least part of that water in your own home, then you don't have to pump so much from your other sources. Now, at the moment, we are pumping from 30, 40 kilometers. In some countries, even more. Some countries, 500 kilometers. We are pumping water. That needs energy. It's not sort of flowing like in a river. It all constantly needs energy. So you can reduce that energy by collecting some of the water you need in your own premises. Reduce flooding. At the moment, especially in the city areas, we have covered all our surfaces with tar or concrete. So there is no place for the water to seep into the ground. As a result, it has to flow down on the drains. And of course, you know, often our drains are blocked. We have a habit of throwing everything into our drains. So when it rains, it's blocked. So there is no place for the drains to take the water. It flows, it floods. So we can reduce the flooding by collecting at each house some proportion of water that will reduce the water that is going into your roads or your surroundings. Then, of course, you can preserve the ecosystem by reducing the flow. At the moment, we are 60% of that rainfall that falls onto our island goes off as runoff. More so from the wet zone, about 40% from the dry zone. So average about 60. So that is the capacity, amount of water we can, at least part of it, we can preserve and retain in use. So different countries use rainwater harvesting for different purposes. I have listed down few of the examples. In Australia, where they face a lot of water shortage because of the long dry months. So as a climate resilient water source, they in some cities or states, it's mandatory to have a rainwater harvesting system. So especially as a secondary water supply. So 9.9% of the Australians drink rainwater, and about 26% actually use rainwater systems. In Germany, since about 1990, they encouraged rainwater harvesting to reduce their sewer flows, because to keep the increase in the sewer system, it is very costly. So they have 2 meters, one to draw water in, other one to take the water out. So reduce on this to reduce the cost on sewer repairs. So to encourage that, they promote rainwater harvesting, and there's a whole heap of commercial industry who are geared to cater for this installing rainwater harvest system in Germany. In Singapore, as you know, they had to rely on Malaysia for their water supply. So to reduce that, they collect all the rainwater and reuse it and give it as new water. So that is all rainwater. And also encourage people to collect rainwater. In Korea, the sponge city concept, Star City in Seoul, where 67% of the rainfall is harvested for either water supply as a water supply source, or to reduce the floods and also to reduce the water bills. So those are the advantage. And in China, especially in the northern part of China, which is the rainfall is about 300 millimeters. They encourage people, they had a big project where they are introducing for drinking purposes as well as for supplementary irrigation. And 15 million people are now using rainwater. And they are irrigating about 1.2 million hectares of land. This project has increased the production by threefold and income by fourfold in China. So that's how successful they have been. Also in Japan, to mitigate floods as well as for water shortages and also for emergencies. As you know, Japan is subject to many disasters, including earthquakes. So first thing that when there's an earthquake happen, what goes off their water supply, because the pipelines get broken. So in each city, in each street corner, they have a rainwater system connecting the surrounding groups. So when there's emergency, especially when there's a fire, they can use that water to survive as well as to douse the fire. In Sri Lanka also, we have in places, as I said, only 60% has pipe water. There are 40% who doesn't have pipe water systems, especially in the dry zone areas or in hilly areas. So for those people also, rainwater harvesting is a solution. So staying on in Sri Lanka, there are about 50,000 rainwater harvesting system, domestic rainwater harvesting system. These were installed in dry zone areas, also after the tsunami in the coastal areas. And they were also installed in hospitals, clinics, remote areas where they don't have water supply. So what good, what good hospital is without water supply? No good at all. So this is a good supply. In schools, for both for drinking as well as for sanitation use. It is also groundwater recharging is practiced. The overflow of the rainwater tank is sent into a well, or the roof water is connected to a well. This has increased the groundwater quality as well as quantity in very short time, especially in the coastal areas, in Kilinochchi. And also in farms, the runoff water is collected at the farm level in ponds. This has a very good recharging aspect, as well as it is a water storage available for their crops. So what is the potential? If you just looking at the roof water, I have taken different average rainfall for different districts and taken a roof area about 100 square meters and calculate the average water that falls onto that roof. So in Colombo, it's about 192,000 liters or 192 cubic meters. So if you divide that by 365, it comes close to, and 4 people in the house, it comes close to about 130 liters per day per person. So that's the daily requirement of water, or even exceed the daily requirement of water needs of a person. So of course, in other districts like Hambantota and Jaffna, it is less, but nevertheless, it at least meet the drinking and cooking needs of a person if you collect the rainwater that falls onto your roof. So if you take schools, for instance, this is schools in Colombo. There are about 347 schools in Colombo. If you take roof area about 1,000 square meters per school, the total rainfall that can be collected from that roof is about, all these roofs are about 584,000 cubic meters. If you put a value to it, I think water board values of cube of water at rupees 60, this goes to millions of rupees. So this is millions of rupees that we waste every year by not harvesting it, not collecting it. Okay, so quality is usually everybody's mind. Is it first thing that everybody will ask is it good quality? If you compare rainwater quality, this is a study done in low and middle income countries, published by WHO. If you compare it, pipe water quality is only a little bit less quality, especially on E. coli. Of course, on chemical, it is much more quality. So it is not a huge concern. And if it's just only bacteria, you just boil the water, you are drinking. It will eliminate all the bacteria. But chemically, it's usually very very much standard with the standard parameters. So if you compare with other available sources, it's much better than the others. So these are a few examples. This is being practiced also in Sri Lanka. This is my favorite. This is MIT campus in Malawi. They are collecting from 3 roofs, the red areas, about 5,525 square meter roof area. And they are collecting into 3 ponds, the blue area in the diagram, which is capacity of 2,315 cubic meters. This caters for about 90 days. So 3 months of no rain, they can survive with this system. And 75% of the water that they need is either come from rainwater or wastewater recycling. Perfectly, it has been running for the last, I think, 20-50 years, and it's still operating perfectly well. These are a few more examples in the plantation sector. This is Forbes Van Walker asparagus plantation in Putlam, Manathavilu, as you know, very sandy area. It doesn't retain any water, so 2 ponds were created using this polythene lining, storing about 7 million liters of water. Usually they used to pump the water from underground. It is saline water, so sometimes they have to purify it also. So since installing the system, they have no water scarcity. The quality has improved. They have less labor and also less pumping from the underground water. This is another example of Malapiti plantation. They have created 75 ponds, collecting about 77 ponds, collecting about 254 million liters of water. Also, they have installed rainwater system for the estate's household, providing water for 64% of their workers. This practice has also increased the soil water retention capacity, soil carbon levels over about 2.75%, and they irrigate about 75% of the land through this rainwater harvesting pot. And also this contour trenching is also practiced there. Industry, there are few industries also in Sri Lanka which uses rainwater harvesting either as a CSR project or actually to reduce their production cost. Brandix is one. 282 million liters of water is collected in Sri Lanka as well as in India for their production use. MAS is another company which 10 to 15% of their water use is during, especially during the rainy season, through rainwater harvesting. They have they collect roof water as well as runoff water from their fields. They are collected into a pond, and also they save about $15,000 per year by having this system. So again, it is economical as well. So what is the enabling environment we have, especially on policy? I'm proud to say Sri Lanka is the first policy which has a national policy on rainwater harvesting since 2005. That is where my pride stops. Unfortunately, not many of us know that because it's not very much implemented. I'll come to that. So soon after that, there was a conference or workshop in Kandy where 7 ministers from SAARC area was invited, and they signed a declaration to promote rainwater harvesting in the region. And also the 15th SAARC declaration, which was held in Colombo, also mentioned about rainwater harvesting. And one of the regulations or recommendation from the policy is to change some acts of the different institutions. One is Urban Development Authority, and the earlier UDA Act, which says whatever water that falls onto your roof has to be discarded quick as possible to the nearest drain. It was changed to say you have to collect certain amount of rainwater depending on roof area and also depending where you are or the rainfall pattern, and only the balance can be put into the drains. This regulation has been in effect since 2009, but I wonder how many of you know about it. Okay, so what are the challenges? Awareness among the communities, officials, professionals. I hope less so after this lecture among the engineers. But I wonder why. Because I think it is the most obvious thing. If you wash your drains or your roof or your gutters when it's raining, how much water that comes down it, and not collecting, I don't know why not. It seems to be the obvious thing. Okay, then initial cost. Of course, anything has a cost. So you need to invest initially to have a rainwater system. As an individual, it might be a little difficult, especially if you are in a poor community or in a low income community. But if you compare how much water, how much money we are spending, or the government or the state is spending to give water supply to each household, is close to 1.5 million. I can construct a rainwater harvesting system for you, less than 200,000. So compared to that, is it really high cost? Or why, even for the state to invest, giving people rainwater harvesting system, it will reduce their cost on improving water supply systems elsewhere, or plus they can give water if you reduce from one household by giving them a water supply. The balanced water you can give to another household or another community of households. So you can reduce the amount that used by each household and increase your number of households which you are giving by supporting to give rainwater harvest system for each household, even in a household where pipe water supply is there. So that's the cost benefits. And of course, what it is free water. Then onwards, you just fill the system, free water, but you need to do some operation and maintenance as an individual. So that is where it has failed. I mean, many of these, you will see these ferrocement tanks, you will say it's not being used, it's not working. Why? Because simply the gutter has been broken, or the down pipe has been broken, and they don't repair it. Not because the concept is wrong. Concept is there, the tank is there, but they don't repair the gutters, or they don't put enough gutters, or repair the tap. So of course, then it fails. Anything it doesn't operate and maintain, even the water board, if the operation and maintenance staff goes home, it won't flow down the pipes. So anything needs operation and maintenance. So we need to have a system to monitor that, or we need to have a system who will support operation and maintenance.
වෙනදට දකින්නේ නැද්ද? වෙනදට ඒගොල්ලෝ දකින්නේ නැද්ද?
Want to mute somebody? Okay, thank you. Okay, then implementation and regulation. I told you the regulation, how many municipalities actually check on this? So as the regulations stand, every household above 500 square meter roof area has to show that they are harvesting rainwater, has to have a rainwater harvesting system. But how many municipalities actually check that? I wonder, only very few, I think. So regulations are there, laws are there, it's not being adopted. Okay, so so rainwater harvesting is essential integrated water resource management for decentralized resource for domestic water supply, aquifer recharge for increase the soil moisture level and conserve the soil moisture levels. It is water for more drops for crops. You can use that water for home gardening, for agriculture needs, etc. Restoration of the water sheds, improving the watersheds, etc. Increase the quality of the water underground or the ecosystem productivity, increase it. Reduce the runoff by collecting, mitigate floods, and also prevent soil erosion as well. And in the urban areas, to manage the water better, to reduce stormwater, use that for supplement the water supply for other use as well. And rainwater is not only just a practical thing. We can combine it with art and culture as well. It can be integrated part of architectural design to improve it. And also it can introduce water conservation practice among children and communities. And also it can promote peace and harmony among communities as well. Okay, so last slide. So use your brains and reduce the drains. And also you talk about the change you want to make, change it at your own home, collect the rainwater that is falling. Thank you. Shall I take it? Okay, I'll take it.
Thank you very much for your explanation. I'm Lakshman. I would like to ask a question. Water bottle mentioned here, the expiry date is 1 year, right? Actually, most of them they don't know, they don't think. But in the housing that we say yes of how long we can keep it if there is no water or no rain?
Actually, we have done some research and we have kept it for 2.5 years. And there is no quality issue there. Unless
there won't be composition change inside.
No, I mean quality stays as long as there's no contamination coming in. You can store and keep the water for about 2.5 years. There is no issue.
No problem, there is.
Yes.
But for drinking purpose.
For drinking purpose, yes.
It's not important. Now, you think inside so the stand mostly cement or the concrete. But it's made out of material.
There could be, you can store as in many materials, tank. I mean, we promote the ferrocement tank because it is locally available material, local labor. But of course, the PE tank is also equally okay. It's quick to install. So, I mean, it doesn't have to be one tank or the other. It can be as long as the material that you are using doesn't add anything to the water that you are collecting. You can use any material.
We can go up to the maximum capacity for household the tank.
Household, generally we have about 8,000 liter tanks. that cost around less than 200,000 whole system. Depending on where you are. So if you are in a dry zone, you need a bigger capacity tank. If you are in a wet zone, you can have a small capacity.
Okay. I'm from Northeastern part of the rural area.
Mm.
That's, there are poor people there. Are there any facility from the government to give, and you are also supporting to build up this tank?
Not that I know of. Yeah, unless this is, you can get technical support from us. We are not a funding organization. But if there is a project that is going on with the water board or the government, they might support you. But no,
That's no.
not that I know.
Last question.
Yes, yes.
When you are training, you already heard about nitrogen percentage is high. But normally I know what is the nucleochemical. When training that water, what is the pH is that, how kind of acidic, when that water?
It depends also on the place. If it's very urban areas, then of course with industrial pollution and things, the pH can be little low.
That means
So we don't promote it for drinking in the urban areas. But in the rural areas, there is no issue except in some pockets maybe. But you don't have to, if you have a water supply, you don't have to drink it. You can use for other purposes. Because you only
in the rural area,
Yes.
how much they need for drinking. Plus their priority is to know water to drink.
many people drink it.
Yeah.
Many people drink
It's,
it.
yes, pH means the acidic, what is the?
Not in rural areas.
Not in-
As far as I know, we have tested and not in rural
Thank
areas.
you.
Okay, well,
Thank you very much.
Welcome.
We've been listening to you for many years,
Sure.
but problem to me is because daily there is but unfortunately, I will say we might have so right now, what we do as a major part of this is storage tank itself. For a while, the tanks seem to be a solution of how price across the roof. So I think we have to go back to the recipient. I believe the way forward to try and get them to the more self-paying rather than somebody higher paper company. So India, like India, some form of support for at least period or consideration to any other system. Now, how is that? You say that it costs 1.5 million to water, actual water, that will be some kind of this is that part of that will be made available for the non-survey. That kind of part. That's only way to go. But we have to try and always fast. Can we always try to move into another consider possibility.
I totally agree with you, sir, because actually, we need to influence somebody, the government or somebody to support these activities. Because for a low income household, it's a difficult task. But we are also introducing finance with like loan scheme system, which seems to work out much better by, people contribute part of the cost of the tank through paying it monthly. But again, we were trying to work with some finance companies to support that, but not very much.
Just a passing thought. Like you are saying that in first one, I think it's a household. You might come and run a sheet. No, but in case of Sri Lanka is also right. But you can have a say. Every household that you are buying. It's all water. And not be a safe part. So that is available for the road.
That's a good idea.
Yeah.
Yes.
That's I think you said.
Yes.
But that is the main problem. otherwise, everything else,
Yes,
everything else can be worked out. Primarily the cost of the, tank is also.
Hi, my name is Anubhav Rasamayana. I represent the organization called the Group of Science Graduate from the State Colorado here at Unite Group. We do some work on rainwater harvesting, but up to now I did not even know that there was a called the rainwater harvesting board.
okay.
So we are talking about awareness, taking steps. Not that you are taking them, not one.
Okay.
Now, how can we help your to help your policy that you are thinking that you will have all the data and that
Not at all, not at all. Please join us. We have been there for the last 26 years, but of course, we have worked more in the rural areas where there is a need. So you can help us. You can help us, as he says, reduce the cost of the storage system. Promote to advocate with the government to give a cess or reduce, give some incentive for people to adopt rainwater harvesting.
how do we get in touch with you?
Please, we have a leaflet. Please contact us. We are at Kalavakkal. Come and drop in and have a chat with us. You are always welcome.
Is there is a perception that in Sri Lanka that rainwater is not good to drink. Is that correct?
It's not at all. I mean, I don't know, it's people do drink. Many areas in the kidney problem areas, that's the only sole drinking water for them. They, I think it's a myth but created by the urban people, not with the rural people.
Lightning causes 90% or something in the water.
Only a small amount,
That's not a problem, not an issue.
not issue. You have a first flush system, yes. Right. Gentleman, will not finish?
Not finished.
It's okay, sorry.
In your view, what is the main obstacle or what is the restriction that people cause reluctance for people to go into rainwater harvesting? Is that also?
One is the cost, and also this not knowing about the quality, as you say. People are not aware it's quite, it's drinkable quality water that we are getting.
If you provide the water inside the house rather than having to fetch the water from the tank which is outside. You provide it in the toilet and inside your tank in your area from the kitchen. Do you think that that will encourage you to go for rainwater?
Probably, but those facilities are not really priority for them. Most of the rural areas. They are used to go into the well to get water. Unless you pump the water into a higher level and then distribute, then there's of course pumping cost. So maybe some houses it will be a encouragement, but not all, I don't think.
Okay.
Thank you. There's some question, sorry, more questions, there's some questions here also, ne? Still go on. Yeah, for many years, the rainwater can be stored, which type of tanks and filter media can be used for long-term sustainability as climate resistant technology achieves SDG targets for safe water supply. So again, as I mentioned, we have stored it for about 2.5 years without any issue on quality. Filter media, usually you can, as the water we are storing, we don't use much filters, except we have the first flush system, where the first washing from the roof is taken out. And then it goes to another debris filter. So if any leaf materials are coming through still or some dust is collected. So idea is to collect much water quick as possible into your storage system. But of course, you can use other filter treatment systems from the water you are taking out from the tank. I mean, you can use UV light, you can use chlorination, you can use everything that's available for your drinking needs if you are not sure. But it's the water that is important to collect. So there was another question about this different type of tanks. I think that doesn't matter, the tanks, material. What are the actors of the government to scale up rainwater harvesting in Sri Lanka? Water Ministry is one, I suppose, with the Water Board, Community Water Supply. Those are the institutions that deals with water supply. And there was a question about, again, the type of tank. Some people prefer the PE tank because it's easy to install. And you can shift it, that's the advantage. If you want to extend your house, enlarge it or extend it, you can shift the tank to a different place. Whereas the ferrocement tank, you can't. But as this gentleman said, the cost is more. The PE tank cost is more. You can have bigger capacity tanks for ferrocement, but I encourage you engineers to come up with a new tank, which is at low cost, more affordable. That would be the challenge. So for more people to use it.
I have a question. How we collect water from the roof? Goes onto the gutter, into the down pipe. Our roofs are literally, majority of roofs are asbestos. After a couple of rains, it gets, healthy formation. Or it becomes black. All the roofs are after some time, it's black. That is not formation, I think healthy or. So when you collect water from those roofs, it will have some impurities in the water.
Yes.
So that's the main issue. The other one is houses close to the roads. We get carbon deposited on the roads, so you get carbon also. And also if you are close to a gravel road, there will be dust. So these are three things I have noticed in these rainwater harvesting systems.
Yes.
Do you have any solution for that?
Yeah. Yeah, no, the first flush can eliminate your dust and the carbon deposit and things like that. So you need to have a bigger first flush system. At least if you allow more rains to wash the roof before you collect it. But this algae formation in the roof, the asbestos roof, you need to clean it. Otherwise, there's no. And of course, if you don't want to drink it, you can use it for your home garden. You can use it for washing your cars, flushing your toilet, all sort of other possibilities. So for drinking, you are only using little bit, isn't it? And even that most of you are drinking bottled water, isn't it?
These are, I would say, these are collaborative problems. If we come to having water, no water, lot of things, pay into listing, you are having a list correct. All these things are, first you look at the first class system, looks after most, and also the amount of water you want to drinking is minimum. So, as you are dedicated for example, you go to boil it and afterwards, that will not all. Forgive me, so these are not actual people in need. And for somebody asked a question, the government doing about this, absolutely that you can say it is not.
Thank you, ma'am. Thank you, ma'am. Very well,
Thank you.
So I want to ask one very small question. So that the media using and collecting this water, amount of water, we will have to manage and check and other things because mosquito. These are the I think the issue with very how can we manage this issue?
Okay, yeah, good questions. And yeah, basically mosquitoes breed on open water. Okay, so if you keep the water you are storing closed, the tank closed, there is no mosquito issue. Unless there is some water retention in the gutters. So if you slope the gutters well, that also is eliminated. So any good water, mosquitoes will breed. But if you keep the water close, it not only prevent mosquitoes breeding, also this algae formation. So it cut out this sunlight. So there is no algae formation inside. Even your water bottles, if you keep it out for some time, it goes green, isn't it? Because there is algae, small microorganisms that grows. So if you keep it close, there is no issue. Thank you. There's also a question about regulation. Yeah, regulation requirement for house planning in the island of Sri Lanka where water is scarce. Very much so. There is regulation, as I said already. So only thing, it is not very well implemented at the moment. Next one, how we can join. Yes, please join us. We have in our website the members form, isn't it? Yeah, so go to our website www.lankarainwater.org. It's there. Please join us. All are welcome to support us. We much welcome you. In cities, due to all development work, all rainwater is lost to the sea in addition to causing floods. Can this rainwater be saved in ground reservoirs and used for maintaining parks and gardens in the city? Yeah, very much so, not only cities, in all the other areas also. So don't think rainwater harvesting only as from the roof water harvesting. As I said, it is also collecting and retaining at different levels to recharge the groundwater. As the gentleman said, now we allow all the water to run off to the sea, and then we go and install desalination plants all over the place to treat that water and bring it back again. Does that make sense? So why do we let it go? We should retain it and reuse it. Thank you.
Mention about laws and regulations. Could you please explain like the notified date, implemented date in Sri Lanka?
The regulation has been in effect since 2009. UDA, if you go to regulation, UDA law, it's there, it's also in our website. So every household which during the planning permission, you have to show that you are having a rainwater system. It depends also on the rainfall band. So say for instance, if you are in a very dry area, you need to show that you are collecting more water. If you are in a wet zone area, the amount is low, and also depends on your roof area. If I remember, 17th March 2009.
According to my knowledge, this regulation is connected to a law.
Yeah, first it was a law, yeah. Then it came from the law, okay, the regulation came. Yes, 2009, around 2009.
permission from the
Yes.
And they were taken. Yes, there are many pictures from the zoo, pillars from Yogi.
Yes,
Yeah, but restricted time.
okay.
So I totally request our chairman to hand over the money of on behalf of the institution of engineering. Speak. Finally, water tank from the engineer London Jason from water farm.
Thank you, sir, and good evening to you all. Council members of IESL, our distinguished speaker today, Dr. Ms. Tanuja Aryananda, the Chief Executive Officer of Lanka Rainwater Harvesting Forum, and all the invitees to the present event. Engineer Prabodha Jinasena, Chair of the Library and Publication Standing Committee. Engineer Mrs. Bhadra Kamaldasa, Chairperson of IESL Water Forum, and all the members of the two committees. All the participants present physically here in the Vimal Surendra Auditorium and all the past participants who joined the event virtually. It is my privilege to propose the vote of thanks on this occasion on behalf of the organizers. In the first place, I extend my gratitude to the resource person of the day, Dr. Ms. Tanuja Aryananda, for sparing her time in this important occasion. Her dedication in promoting rainwater harvesting in Sri Lanka is remarkable, and she had brought immense fame to the country through various programs launched in Sri Lanka that were acknowledged globally. Thank you, Madam, for sharing your valuable experience, and we appreciate your dedication in promoting these innovative technological solutions to fix the current water problems in the country, especially the problems faced by the marginal groups in the society. Though rainwater harvesting is a vast subject, you presented it in a simple manner. Thank you again, Madam. And the informative leaflet provided by the Lanka Rainwater Harvesting Forum was also a nice idea to aware the audience with. I would also like to thank the President of IESL, Engineer Professor Anjit Disanayake, CEO Engineer Neil Abesekara, and the council members for their support throughout this event in many ways. I would like to thank Engineer Jayantha Gunatilaka, who introduced the speaker to the audience. And I would like to especially acknowledge the various support provided by the team of IESL Secretariat. I would in particular like to mention the name of Mr. Chamila Priyantha, who coordinated all the logistics on behalf of the Secretariat, though it is a holiday today for IESL. Very especially, I would like to thank all the participants who have been with us during the present event, both physically and virtually, because it was your interest on the subject that made this event really a success. Finally, I would like to extend our sincere thanks to the Planning Committee, particularly Engineer Prabodha Jinasena, Chair of the Library and Publication Standing Committee, and his team, and Engineer Mrs. Bhadra Kamaldas and IESL Water Forum for organizing this event jointly. I apologize if I missed acknowledging any person who supported this event by any means, and I thank you all once again. And please be informed that if you wish to recap this informative presentation, it will be soon be available in the IESL YouTube channel. Thank you, ladies and gentlemen. I wish you a pleasant evening.